Yeah, we're going to want to talk about functions mainly here today. However, before we talk about functions, let me mention another term that's a relation. Function will just be a specialized relation, but a relation, well, that's a pretty open category right there, because a relation is just any correspondence between two quantities or sets. Any correspondence between two quantities or sets. That's a correspondence. Like I said, that can be like two examples here: time with the temperature at that particular time. That would be a relation. You got your time and then the temperature at that particular time. That's a correspondence, so that's a relation. You know, we'll focus on numbers, but quantities with numbers, time with temp. But it could just be sets of, like here, let's say students with their classes they're taking. All right, so that sets up a relation because this student has these classes and this student has these classes. So that's a correspondence, that's a relation. Now there's different ways you can represent that. Of course you can do here just like a table. Time with temp. Let's say at 10 o'clock you had 50 degrees. 11 o'clock it was 52 degrees. At 12 o'clock it was 57 degrees. Okay? That's one way you can do it. Over here, students with classes taken, that may not work so well at the table, so you can even kind of use like a chart. So we got Jack and Jill, and we got chemistry, math, English, history, just name a few. All right, so Jack's taking math, chemistry, math, and history, and Jill's taking math and English. So lots of ways we could set this up and represent this correspondence. Okay. Now another way we could define a relation is we could just set it up as ordered pairs. So I think that's the way this book chooses to define it. A relation is just a set of ordered pairs. So that's just another way to write it. So if we take the time and temp example here, we could say, well, it's 10, 50, 11, 52, and then 12, 57. And so that set of ordered pairs could represent the relation. So it's just kind of understanding what we've got going on here. All right, now another term we could use also here. All right, so if we set this up, probably the way we would do it is say, well, what we're doing is we're taking 10 o'clock and then matching it with its temperature. So 10 o'clock is the input and 50 is the output. So that's another way, another term here. So usually the way we typically do it is the first value is the input, and the second is the output. Okay, so just another couple of terms here. Now, writing them in these ordered pairs, then, right? Which would we usually consider the input and the output between X and Y? Well, writing them in ordered pairs here, the x would be input, output would be the y. So that's typically the way we do it. So these are typically the x's, and the outputs are typically the y's. Right? With me there? Okay. All right. So let's set up here, define our function. So here's what a function. A function, then, all right, so a function, like I said, is a specialized relation. A function is a relation for which each input value corresponds to exactly one output value. So it's, like I said, it's a specialized relation. Each input value corresponds to exactly, meaning there's one output that goes with each input. Exactly one and only one, another way to put it. So my examples of the relations over here, all right, so would the time with the temperature relation, would that be a function? Well, each time we put in, would we have one, more than one? No temperature? We'd have exactly one temperature, right? At 10 o'clock, there's one temperature for that day. At 10 o'clock, there's one temperature in one particular site we're talking about in our location right this moment. All right, so each time goes with one temperature. We're talking about for one location. All right? So yes, that's a function. Is the student with the classes example here that is that a function? Well, again, the first one's the input, the second one's the output, considering that way. So if I input Jack, how many outputs are there? Looks like there's 3. If I input Jill, there's 2. So is that a function? No, a function, one input gets one output. So this is not a function, you see. With me? Good? All right, so that's the idea of function. One input gets exactly one output. Can't have more than one output for each input. Okay, now, of course, we're more interested in the number side of these things, an equation side. So we can represent relations by equations. Y equals 2x, that would describe a relationship between x and y, right? If I put in x is 1, I get out x is 2. If I put in x is 3, I get out x is 6. So that's a relation. Is it a function, though? I don't think it's too hard, hopefully, there to see. So if I, again, consider the x as the input, and then the y is the output, right? That's how we basically define it over here. In ordered pairs, we let the x be the input and y be the output. Is that a function? Well, let's think about it, all right? So if I put in an x, am I going to get a single y out, or do I get more than one y out of that? I get a single y, don't I? If I put in x is 1, I get y is 2. If I put in x is negative 2, I get y is negative 4. So, and there's no other option, is there? We're not going to get a second y out of one x. So each x goes to one y. Would you agree? This is a function. Y equals 2x is a function. All right? Not all equations are functions, but there are a lot of them that are functions. Now, Say all this to here's where I basically wanted to get. What we have is what is known as function notation. And all that basically does is it takes your output value and kind of gives it a name, and well, you'll just, all right, if you're not familiar here, here's what it is. All right, so what I do is I take my output, which is my y, and I'm going to replace it basically by, I'm going to replace this one by f parentheses x equals 2x, f parentheses x. That's called function notation. And here's what it means. Usually we read it f of x, the f parentheses x, that's usually not how we say it, but it's f of x. Here's what it means though. The f is the name of the function. This x right here, well, that symbolizes your input value. Right? X is the input, so I put the name and then inside I put the input. Then over here, of course, this you could just say that's your, the 2x is your defining expression for your function. What is the function? Well, it's 2x. But another way, that's going to be your output, right? So anyway, it's just another way to represent some equations and some circumstances that are functions. All right. Well, the first thing we're going to do here is work with that notation a little bit. Let's say I've got f of x, change it up a little bit. F of x equals 3x minus 4. So one way to utilize this notation is this way. Let's evaluate for this function. So I've renamed f a little different. 3x minus 4. And so I want to evaluate or find the value for, I think the way the book phrases it, find the value for f parentheses 8 or f of 8. Well, in this case, like it shows here, my input I've chosen, if you will, I've chosen to input 8. And so what that means is I go to my defining expression and do just what that suggests. I input 8 for the x. So it's just, this just gives you the number to plug in for x. That's all it does. That's your input. So you input it into your defining expression. 24 minus 4, that's 20. Okay? Easy enough. All right, now, some functions, all right, so that's a pretty simple one. Let's say I've got, let's change it up. Let's say I've got g of x equals x squared plus 3x plus 4. That's a little different. And in this particular case, I've changed the name, I've changed it to g, so functions don't always have to be named f. They can be named g or h or any really letter you choose, just about. All right, so on this one, let's see, g of, let's do g of 5. Well, again, that means input the x to be 5. So in this particular case, I've got two places to input it, right? So I've got 5 squared plus 3 times 5 plus 4, right? 3x is 3 times x. So what does that give me? 25 plus 15 plus 4, that's 44. Sound right? Yeah. Believe that? Okay. Now I can get, here's about as tricky as it'll get for us. All right, so g of -2. We're going to input -2. So you just have to, watch your signs here. So I input -2, so wherever x is, I put in -2, so that'd be -2 squared plus 3 times negative 2 plus 4. Like I said, just have to be careful with the signs. If I square negative 2, that's a positive 4. 3 times negative 2 is minus 6 plus 4. So you wind up with, if you do all that out, you get to positive 2. Is that okay? Any question or concern? All right. Now, let's go back to f of x equals 3x minus 4. This one. Okay, so one other thing I'll ask just here. So let's find x for which f of x equals 9. So I've got, back on my original function there, f of x equals 3x minus 4, I want to find the x for which f of x equals 9. So in this case, I don't have the input value. That's what I'm actually trying to figure out, what the input value is, right? The x, I'm trying to figure out what x is here. So what this is telling me, well, this is really telling me what to do right there, because it says I want f of x equals 9. So in other words, for f of x, in this case, I'm going to replace f of x by 9. So here's f of x, so I'm going to replace, in this case, the f of x with 9 instead of what we were doing before. Is that okay? We changed it around a little bit. F of x is 9. So this whole thing right here is 9. And so it just sets up a little equation, simple, keep it to the basic equations here. So add 4, solve for x. Add 4, so you got 13 equals 3x, because those go away. Divide by 3, so you got 13 thirds equals your x. Okay? So that's a little bit of a change, but like I said, the problem tells you exactly what to do in that particular case. Question or concern?